So really, to start out with, I mean, the internet has created two new breeds of application. On the one hand, you have your traditional web application, usually a website. The client is usually a web browser somewhere. And the popularity of web applications, obviously, for both intranet and internet applications has been incredible. And then on the other hand, you have the new web service model, where your application and the developer can actually use the internet to communicate and enrich their application by taking advantage of the internet to make programmatic calls. So the question arises, how do I, or in this case you, the C++ developer, take advantage of these two worlds of operation, both the web application development and the web service development? And while this talk is based on ATL server experience and the ATL server library, definitely for the web service discussion, that affects every C++ developer. Because if you do want to use web services from unmanaged C++, then ATL server is the way for you to do that on the Windows platform. And of course, there's a lot of other new services coming out. Things like .NET MyServices, which I'm sure you've all heard about. And again, it's about using these from an unmanaged C++ perspective and about maintaining your C++ programming model when you're working with all these technologies. And the C++ programming model is the power, the performance, the control, the flexibility and extensibility, the reason that you program in the C++ language. You could always drop down to the lowest level. I mean, that's one of the benefits of developing in C++. And in this case, the lowest level is ISAPI. And ISAPI provides very, very basic building blocks for your application. But it is hard to create even a traditional web application just on ISAPI. You have to worry about thread pooling, caching, session state. There are really none of the core services that you need to build a real-world web application. And what about web services? Not only do you need a lot of this other functionality you need for a normal web application, but you also start having to worry about passing SOAP, marshalling data into your application. ATL Server is the library designed to solve these problems for you. And my name's Pranish Kumar. I'm the program manager on the ATL MFC libraries, or one of the program managers. You can find more about ATL Server at the MSDN site, and you don't have to follow the entire link. You actually, if you go to the next generation, it'll have some articles on it. I also recommend people go to the got.net site. We just recently added a C++ section to that, www.got.net.com, and there is unmanaged C++ stuff there as well, and many of the samples you'll actually see me demonstrate today are available for download off that website if you'd like to get them for yourself and play with them. So in this talk, we're sort of going to cover three separate topics, and really the talk is in two sections. And the reason the two sections will be quite disparate is that this is actually two talks that were merged together into one. So again, I hope the timing works out well. It is two separate talks being sort of pulled together. So in the first half, I'm going to look at web service creation with ATL Server, and then we'll take a look at how you can consume .NET MyServices today, and we'll also take a glimpse at what it will look like in the future. With this release of Visual Studio, the ATL MFC team didn't focus on getting full .NET MyService support, so it's not as easy as just point and click, which is obviously the goal for a future version. In the second part of the talk, what I'll cover is some general tips and tricks we've learned from working with real-world developers working on real-world applications in ATL Server. We get an opportunity to work with a lot of the early adopters and a lot of large ATL Server web applications. And throughout that time, we see a number of practices that, or mistakes people commonly make, or things that people don't design quite right in their application. So hopefully this section will help you get the most out of your web application in general. And while it's an ATL Server experience, I don't think that section is really that ATL Server specific. I mean, anyone developing a web application could use a lot of the tips and tricks. And again, with that section, it might be some stuff you already knew, but hopefully there's a few points in there that took you by surprise, or maybe there's something in there that you realize you need to document for new developers joining the company for a best coding practice type document. So the question I'll start out with is, what is ATL Server and why did we create it? ATL Server is a part of the native C++ libraries, the ATL MFC libraries. The ATL Server name comes because it is an extension almost of ATL. It doesn't require that you have really a knowledge of templates. It does use some templates, not as extensively as ATL, and it's not COM-based. The reason it's an extension is it builds on top of ATL, and it's built with the same ideals and the same model. And that model of ATL is this lightweight, very flexible library that you can use anywhere. But it's predominantly a class library, whereas ATL is really predominantly, I would say, a template library. It was designed to preserve the C++ programming model, and again, this is really from the ATL background. It was designed for performance, control, flexibility, and extensibility. And the way we look at this is we want to be able to enable people with very simple building blocks, and that's really what ATL Server is made up of. It's a higher level on top of the ISAPI of these separate building blocks that you can use separately. If you just want the caching, you pull it over, you use it in your application, you'll just pay for the caching. But at the same time, this network sort of fits together, and it forms this very rich framework. So if you do buy into what you would probably call the ATL Server model, you'll get this very rich development environment, and you'll get a lot of functionality. And the way I like to look at it is it's the code you would have otherwise written yourself. In another sense, ATL Server is also what I would call a traditional C++ library, in that it's just source code. There's no binary files at all. So it's all header files, it's all source for you to see. You can step through every line of code. Everything in your application is generated by the wizard, so there's like no hidden magic or binary file you're relying on. And this is really critical, especially on a server application, to maintain that control. I mean, if you have a mission-critical application and you really do need to step through, or be able to step through every line of code and see what it's doing, then that's what ATL Server gives you. On the web service side of things, it's also good to point out that ATL Server is SOAP 1.1 and WSDL 1.1 compliant. So I know that a lot of you have been bombarded, no doubt, throughout the conference about web services. It is a big change in the direction of Microsoft technology. And I'd like to just take a quick moment, though, to just take a native view of web services, because while it's an oversimplification, a lot of the ideas behind web services are nothing new. It's just a new way of doing it. So, for example, you can look at SOAP as just a new RPC mechanism. It's really just a way of making remote procedure calls over the internet, and you're using HTTP as the transport mechanism by default. With ATL Server, you can actually change the transport mechanism to be anything you like. And you have XML as the packaging. So the SOAP document uses XML. And really, this enables a new generation of remote procedure calls. You can now, go over intranet or internet sites. You can go over firewalls and things like that, and make these very rich programmatic calls, and really enable your application with a bunch of services. The best way for a native developer, I think, to look at WSDL is as an IDLE for web services, particularly if you come from a COM background. It really just is an interface description language for your web service. The WSDL is based on XML schemas and the XSD data types. And again, it's really basically just because both COM and web services, the way the technologies work, rely on having very clearly defined interfaces. You need an interface description language to help you define those interfaces easily. And ATL and ATL Server also take advantage of this by enabling COM developers to leverage their existing skills in the web service world. And we do this by making web service development with, if you use the new Visual C++ attributes, which we'll see later today, we make web service development very similar to COM development in terms of feel of the code. And so hopefully it'll be easy for ATL developers in particular to create web services. We also provide functionality so that if you have existing COM components or if you create a web service, you can expose it as the other thing. So if you're an existing COM component, you can very easily, in 3 or 4 lines of code, expose that as a web service if you want to. So I'll start off, and for those of you who have seen ATL server talks before, the first couple of slides, the next 1, 2, 3 slides will probably be familiar to you. I ask you to bear with me because the rest of the material is new. This is a new talk. But I really need to give people an introduction, for those of you who aren't familiar, with how ATL server works. So basically, when your HTTP request comes in from your client, IIS receives the request and gives it to the appropriate ISAPI DLL. This is the traditional ISAPI programming model. Your ISAPI DLL in the ATL server case is the place where it's really just a request dispatcher, but it's also where you would put any global functionality that you want to expose. Caches is a good example of that. Performance monitoring is another example. Once your ISAPI DLL receives the request, like I said, it's predominantly a request dispatcher. It dispatches that request to your application DLL, and you can actually have several application DLLs. The reason we broke this model out is that IIS by default will lock your ISAPI DLL. So if you want to change that DLL, you have to actually restart your web server, the IIS process. In this situation, you no longer have to do that. If your application logic is in your application DLL, which is how we envision it, then you can actually change your application DLL on the fly and hot swap it without having to restart your web server. So what does an application DLL actually consist of? Well, an application DLL actually consists of what we call handlers, and these are really just request handlers. A handler is simply a class in your application DLL, and it's a class that usually derives from C request handler T. And all that means is that class and the methods on that class are designed to handle incoming requests. And we'll see how that works and what that looks like in just a moment. You can use attributed programming to simplify your code. Like I said, attributes are a new thing in Visual C++.NET, and they're basically designed to help programmers focus on getting their application done and not so much on some implementation specifics. They're designed to generate boilerplate code for you. And we'll see a little how that looks like in just a few moments. You really can simply look at your job as creating the methods that will be exposed as web services. It really is that simple. You write a class, you write the methods, and by using attributes, that's really all you have to do. You put an attribute on the methods you want to expose, and then they're web services. We've tried to make the model as easy to use as possible. ATL server will also automatically generate the WSDL for you. Even if you're using very compound types or complex types, it'll go ahead, it'll generate an accurate WSDL. And even if your situation is very peculiar and it doesn't generate a perfect WSDL, it definitely gives you a very good starting point. You can also use inline IDLE, which actually relies on the attribute technology I was talking about earlier. You can use inline IDLE to make your web service development a lot more like COM development. And you can actually use that to expose your web service as a COM component. And unfortunately, we won't have time to look at that today. Although if anyone's interested, they can talk to me afterwards and I can point you to some samples that show you how to do that. The ISAPI DLL is the other big part of this picture. The ISAPI DLL, like I said, is really just a request dispatcher. It really doesn't do much else. But also, it will provide any application-wide services if they're required. Your application DLLs live on a thread pool. Like an application DLL, you can't guarantee which application, which instance will receive an incoming request. Every single request will go through your ISAPI DLL. So it's a great place to provide caching, performance monitoring support, or other things that need to be global to your application. And again, we provide this to you as source code for ultimate flexibility. So ATL server with web services, and this is really a key point I want you to take away, because a lot of people think, oh, it's ATL, it's tricky. It really isn't. On the server side, you write the methods that you want to get called, and on the client side, you just call those methods. And on the client side, I talked a little bit about the server side already. On the client side, there's a utility, a command line utility called sproxy, sproxy. And that's what gets run if you use the add web reference dialog. And that actually will generate the glue code for you. And basically what that means is you point it to a WSDL description, and Sproxy will actually generate a C++ class for you. And then when you're calling the web service, it's just like calling methods on that class. And it really is very simple. And the best way to show you that is actually going to a demonstration. If I can get a switch, please. So let's create a new project. Usually I take people through the wizard. This time I really won't. But what I'll do is create a project. We'll call it basic because it's going to be very basic. And you can see with my funny sized fonts the wizard works very well. So I'll just click finish. We won't go through the wizard. I just generate a basic ATL server web service project. It automatically generates all the files I need for that. So let's go to Solution Explorer and open really the core file. And you can see if we open that up again that you do have an ISAPI project there, and it's all given to you as source code. So you can see if I click on a file, it's all just a normal source code file. So let's take a look at this. I'll try and build and deploy it while we wait. And I'll take you through the basics of this application. So I start out by showing you something that COM developers will be very familiar with. This is now how you can do COM development with these inline attributes. And as you can see, it's really just inline idle. So I have my interface, iBasic service for this simple web service. And you can see I have one method that I want to expose. And in this case, it's a hello world method. It takes a beaster in and gives a beaster out. So very, very simple. And this is exactly how COM looks. And you can actually put like extra information specific to COM. So it actually did build and run. And you can see this is the WSDL it generated for me. I did a Control F5, so it tries to run the application. So we won't worry about it for the time being. I'll go back to the code. And what I want to show you is we have the C basic service class that actually implements our hello world method that we want to expose. You can see it inherits from iBasic service, which is the service we created earlier. I've used an attribute to mark it as a request handler. Earlier when I was saying you have to derive from C request handler T, that's actually what this basically does. It derives from C request handler T and sets it up as a request handler. The gen basic WSDL is used to give me a pointer to the WSDL. And if we go back, you can see, for those of you with excellent vision, that in the address bar, it's actually got handler equals gen basic WSDL. So that's how I get my pointer to the WSDL. And let me just copy that because we'll need it in just a second. So you can also see I've marked it as a SOAP handler. And what that says is this class will contain methods that need to be exposed as web services. Well, what does that mean? That means that incoming data to the methods on this class that we mark will need to be decoded from SOAP. And our output parameters will need to be encoded to SOAP. What do we have to do for the method itself? Well, we just slap on the SOAP method attribute, and then we create the hello world method. You take a beaster in, you return a beaster out. And if you look at the functionality, it's very simple. This simply prepends a hello to whatever you pass it, and it postpends the exclamation mark. So you give it a whirl, and it'll make up the standard hello world sentence. So you can see it really is that easy. I mean, all we're doing here is creating a method. We have to put an attribute on it. All we have here is a class. We have to put like 3 basically stock lines of attributes. And all we have here is an interface, which describes our interface. It's a very, very simple model. If you don't like attributes, there is a compiler switch / capital F little x, I believe, fx, and that will actually generate the code for you. So you won't. So it'll actually generate a C++ file, and that will contain the actual code that's generated. Attributes themselves aren't actually compiled by the compiler. What happens is the compiler goes through your code. As it goes through the code, it calls a special attribute provider, and the attribute provider then has a chance to inject source code into your application. And the reason this is more powerful than a typical wizard is you can use all the information the compiler knows about your code to create very, very rich code generation. If you go, I think, to the MFC talk that's on later today, I believe they're actually demonstrating like a COM component, a self-registering COM component in like 3 or 4 lines of code. It really is amazing what you can do with these. These are very, very different from the managed attributes, for those of you who have looked at those. It's a completely different model. These are actually much more powerful. So let's create a client for this application. We've seen how easy it is to do the server. So what I'll do is I'll add a new project, and I'll make it very, very simple. I like to keep things easy, so I'll just create an empty console Win32 application. It doesn't get any easier than that. No source files or anything. So we'll add in a new source file. Where's CPP? There we go. And there it is. And you don't have to watch me gruelingly type out code. Luckily, I have it just ready to go. So you can see here, this is what it looks like to use a web service. You know, the only thing you're wondering is, oh, he hasn't connected to the web service yet. So let's actually go ahead and do that. And like I said, you can run the add web reference dialog, as I will now, or you can run this proxy command line utility. So I right-click, I start the add web reference dialog. I paste in the link to my WSDL file. Luckily, our dialogs resize so nicely. And if everything goes according to plan, I can click the add reference button. And it runs this proxy command line utility. And you can see it's added a basic service.h file to my application. And I won't go through it now, but you can see there's a decent amount of code that's been generated for you that does provide the glue. And these services interoperate perfectly with like the with managed C# or VB web services. So we've designed it with interoperability in mind. So let's go back. Let's just look at what my application should do. This is stock code. Let's look at how it works. So you can see I'm basically just, I go into the namespace, I co-initialize null, very typical. And really you can see here's where the real service creation is. So all I do is instantiate a class that's generated by the header file for me. I create some CCOM beasters for the input-output, and then I just call a method. It really is that simple. If I run this application now, and everything works according to plan, it'll just work. A little console dialog will pop up. You'll get the hello world return that I'm printing out. And for those of you again who can see, there is a hello world. Unfortunately, you can't preset this. But for those of you who can now see, hopefully, there's a hello world return. So it's just a very, very simple application, but it shows you how easy it is. So let's go back to the slides. And let's just cover 3 of the tenets of ATL Server Web Services. Performance, control, flexibility, and extensibility. So I'll start with performance. Performance was very, very important to us throughout the design process. Performance is not something we think that you can just tack on at the end or worry about at the end of your design. Throughout the development of ATL Server, web application and web services, We continuously tested performance. We continually measured ourselves. And we're really happy with the results. I've looked at a lot of other implementations, and our performance really is an industry-beating performance in this regard. And for an example, just for a number that's as meaningless as any number someone shouts at you, on about a dual processor machine with just a simple SOAP request, I would expect you to get somewhere in the order of 1,700 requests per second using ATL server over the network. Control, flexibility, and extensibility really tie in more closely. They're all interrelated. Control is a big thing that sort of gives you the performance for a start, because control means you can dig down into ISAPI, and that's what the ATL server model is. If you don't like a part of what ATL server gives you, you can go in and you can replace it. And that works in reverse too. If you have an existing ISAPI application and you're adding functionality to it, you can have your full application, you can go up and pull in just the part you need. And I've seen people just pull in the caches for an existing application, or take out thread pool because it was inefficient. And it really is a very flexible model that gives you control and performance. It means more than this, though. It means we've given you enough power that if you don't like the way something works or you want to change it, you can. And that means even if we didn't understand what your application was going to do, you can still do it. And the best way to show this is, again, with another demonstration. So if we bounce back to the demo machine, I'll show you two samples that I love. One of them ships on the CD, and one of them will actually be the basis of an article very, very soon. So this is my very gimmicky presentation. As a libraries presenter, I don't really get much chance for the gimmicky type, flashy applications. This is as close as it gets. So this is actually a SOAP web service implemented using floppy disk as the transport mechanism instead of HTTP. So while it's not a very real-world scenario, I would hope, unless people are very, very fast throwing floppy disks around the office, it is a good proof of concept, and we do have examples using like TCP/IP and MSMQ. So as you can see, I run the client. I simply... you can see it's actually going to the floppy disk. So let's try it again. It's actually the B drive. This is confusing me, but... So the request was successful. If I go to the... I run the floppy server. Nope. This is what happens when you can't see what you're doing. Oh, I'm in the wrong directory. Okay, so I give it the A request.xml. B. Thank you. B /request.xml. So again, it's actually on the floppy disk, and Windows 2000 used to actually complain when I pulled the disk out, but Windows XP is obviously a little smarter, so that's not good from my presentation standpoint. But let's put the disk back in. I can now give it the output file. And I can now say that the response is ready. And there you go. You can see the hello user return. And if I go to the B drive, you can actually see the request and response. And if I just edit one of them, and we won't go into the details of it, but I'd just like to show you that it is an actual SOAP request. So you can see there's a SOAP envelope, a schema, and everything else. So it works. And it was really, it's like 50 lines of code. It's a very easy sample to look at, and it's pretty cool. Another one that I like to show that, like I said, is not available yet, although will form the basis of an article, is that when we created this, we didn't really think about about the asynchronous case that much. And one of the big things that comes up is, oh, how do I do asynchronous? And one thing we found is that it's very, very easy to plug asynchronous capabilities into ATL server. There is a sample on the CD showing an asynchronous server. And this is a sample that, like I said, will be an article and will eventually be published to the web that actually shows an asynchronous client. So it's not a very flashy example. I run the async client. You can see that the results actually returned in order, which is very unusual. So if I run it again, hopefully we'll get, yeah, there you go. The results are in a different order. So you can see that it just responds asynchronously. And every time I run it, I can't guarantee what order things will be processed in. But it's very, very cool. And I recommend you look at the server-side one. And when the client one comes out, it'll be useful to look at. So let's go back to the slides. And I'll talk briefly about .NET MyServices. So ATL Server will in the future work with .NET MyServices. And the idea eventually will be that you'll be able to consume a .NET MyService just like any other web service. You run Sproxy, the header file is generated for you, you just incorporate it into your application. With this version, we don't have that functionality, but again, the flexibility of the ATL server model means that it's not that difficult to plug in .NET MyServices. You do end up having to do the SOAP, well, not the SOAP parsing, but the XML parsing yourself, because the .NET MyServices Hailstorm in a box isn't quite SOAP compliant. They have some additional features to get their rich functionality. But we do have a sample, and this is again available on got.net. If we go back to the demonstration screen, what I'm actually hoping I'll be able to do is be really, really flashy this time. And we'll see how that goes in just a moment. So you can see this is just a simple SRF file or ATL server web application. I'm actually connecting to a machine in Redmond where some of my colleagues are hopefully playing the game, if all went according to plan. So I simply put in my credentials to connect to the .NET MyServices server. Some of you may not be able to read that. I'm sorry about the font sizing there, but you can download this and play with it yourself. So again, the graphics are really just a bit screwed up because I've increased the font size. But you can see it uses the Passport SDK. So we'll do a Passport sign-in. And I actually won't sign in as myself. I'll sign in as one of my teammates. So once the sign-in process completes, it refreshes. I can now start playing the game. So if I click here, I'm now on the board, and unfortunately there's no one back in the office playing the game, which is a pity. But it is a multiplayer game. If they were playing, you would have been able to see them. They were supposed to be online at this time, but obviously something went wrong. You can see now if I try and shoot, I can't. I have to purchase a license. This is obviously a very Microsoft-developed game. So I can go over and actually use the .NET MyServices wallet, and you can actually add credit cards. So because of the font size, the graphics aren't coming up great, but I'll just pay with one of my existing cards. And I can now, when I click to activate the control, I can now shoot. And if there were other players there, I would actually be scoring points by killing them. But it is a good sample that shows you how to use the .NET MyServices wallet. It shows you how to use the contacts. Now, the real reason I did want someone else to log in, and this unfortunately isn't possible just off a single machine, because what I can do is play multiple instances of a machine. But what I would have liked to show you is we've actually also added some features that are only available in Windows XP, and they build off some of the new Windows XP APIs. And that's the real-time conferencing features. And so what this game actually has in it is there's an instant messaging system. So if there are other players, I could type an instant message. And again, this really doesn't demo well without other people playing. But let me just try. What I'll just do quickly is just shrink the font back down and see if that shows up anyone. I'm not sure. No, there's no one there. So I can type an instant message and send it. I just click on the player's name I'm sending it to. You can see I can invite my contacts. It'll send them mail. It also actually has video conferencing, which is what I was trying to show you, which is why I have my little camera here. Oh, I think I just killed it. But it also has video conferencing. You can have a look at the sample, and you can actually it uses XP real-time conferencing APIs to produce this really rich environment. And it's a good example of how you can do that in your own applications. So let's go back to the slides. And that's actually the end of the demos. I usually like doing demo-rich presentations, but this second part is what we're on to now, which is tips and tricks with ATL Server. And hopefully some of these may be non-web application specific, although they really were designed with web application developers in mind. So let's start off with COM. And my first bullet point might be worded a bit harshly. There really is nothing wrong with using COM. Actually, a lot of people will tell you that, don't use COM, it's no good. There are actually plenty of very good reasons to do COM. COM is a great technology for what it's designed to do. What I don't want people doing is you see a lot of people who go out there and they create an application using COM, and they really didn't have any need for COM. They weren't taking advantage of any COM features. They just used it because they were ATL developers maybe, and that's what they knew, or because that's just how they architect their applications. They always use COM, and it just adds an unnecessary overhead to your application. What are good reasons for using COM? Well, maybe you have existing well-tested components, or they provide complex functionality. There's no reason not to use those components. Go ahead and use them. Obviously, there's a lot of people in that situation where there's a lot of code, a lot of effort and time that's been put into these components. If they're there, you want to use them in a web application or web service, go ahead and do it. Using COM Plus is another great reason. COM Plus provides a lot of services. Transactions is one of the more popular ones. And if you are going to use COM Plus, if you really do want to do things like transactions on Windows, COM Plus is the best way to go in my opinion. And if you're going to use COM Plus, you need COM. That's another great reason. If you want to just componentize your application, if you have a very large application with developers all over the place working in separate teams, or maybe the application isn't that large, but the teams are just very separate, COM provides a great way to just work in terms of components, so developers can focus on their own component and not worry so much about interoperating. It's something Microsoft uses a lot in its own products. So these are great reasons to use COM. The point is, when you're designing your application, show a need for these reasons before you use COM. And if you do use COM, there are some common pitfalls people fall into. And the first one, I've seen people not even using COM fall into this one, where they use OLE automation types. OLE automation types are designed for use with COM. But I will see people who use beasters and things like that without even touching COM. You shouldn't do it. And you really shouldn't, if you're using OLE automation types, they're designed to communicate with COM. Sure, if you're just going to do something very simple, you can use the beaster or whatever in your code. But if you're going to do something complex, and if you're passing around types inside your own application, then please convert it to something more suited to that, like a C string. Because we often find a lot of applications where people have a beaster, they start using it, they pass it off to someone else, that guy converts it to a C string, does a bunch of stuff, goes to, then puts it into a beaster to send it off to the next guy, and it ends up into a big mess. And the OLE automation types do, in some applications, lead to scalability and performance problems. So that's the real reason to not abuse them. They're fine for what they're designed for, but if you use them everywhere, you can run into problems in terms of the scalability of your application, and it's something we've seen on a few occasions. The process and security model in COM, also, it's very important that people understand these when they're creating an application. And this is something else people can make mistakes in. And the first point there really is sometimes it'll make sense to be running in your web application process, but you have to be aware of the cost when you do that. If you're in that process, then if there's security vulnerabilities in your code, someone might be able to bring down your server. You're running in process, so it's going to take up memory in the IIS process. It's very important you understand when that's important and when it's important to have it outside of your process. So you have it outside, you get that separation that you're after, but you'll have to pay a cost for cross-process marshalling. And one of the key mistakes people often make is they'll put a component outside of the web application process and pay a huge cost. If it's a component you're using all the time, you're going to end up paying a heavy cost. So you just have to be aware of that and understand the implications of where you put your object. Understanding the security model is also a twofold problem. On the one hand, there are situations where people deny themselves access to objects they should have access to. So it's very important that you go out there and you test logging in as unprivileged users and making sure the application works as you expect it to. On the other hand, the bigger problem is when an unauthorized user gets access to something they shouldn't. And again, if you test it by running your standard users and trying to hit some of the unauthorized stuff or stuff they should not have access to, you'll quickly see if your COM security model is up to scratch. And it's an easy mistake to fall into. One of the biggest parts with COM and one of the biggest problems we see is in terms of marshalling. You really need to understand the difference between good versus bad marshallers. So firstly, you need to understand what marshaller you're using and how your interfaces are being marshaled. At some level, you really do need to understand how that's working. And you have to understand that for most applications, the default marshaller is not going to be the most efficient. It's very generic. It's designed to suit a wide variety of applications. And if you really are doing a server-side application that's supposed to be highly performant, it's supposed to be very scalable, then you don't want to use the default marshaller in most situations. An example of a good marshaller that's basically given to you for free is the ATL proxy marshaller. The wizard-generated marshaller, when you run the ATL wizard, is an example of a very good marshaller. People often want to create custom marshallers. That's another way to go. The mistake we see people fall into there is someone creates a great custom marshaller in the company and everyone else starts using it, but it's not tuned for those other applications. So make sure if you're using a custom marshaller that you've tuned it for your application, because there will be application specifics you need to take advantage of. And almost everything you do in terms of performance, except for very high-level stuff, is taking advantage of application specifics. And that's a lot of what this is focused on. There's also, if you're going to use COM Plus and MTS, there's also a lightweight marshaller. You can set an option there to use this lightweight marshaller that may be much more efficient for your application. All of the points are not going to be COM. I brought up COM first just because it is one of the common ones for ATL developers. The other thing I like to point out is, I've told you, don't use COM Plus unless you need to. That's sort of the one extreme. The guy uses every technology he can get his hands on. At the other extreme, you have the person who doesn't want to use anything, who wants to recreate the wheel every time. And that really will lead to numerous problems. We have seen a number of people who have tried to implement basically COM Plus themselves, and it never works out right. COM Plus provides a lot of functionality, transaction, security, logging, object pooling, a bunch of other stuff. And if you're going to use a lot of this sort of functionality, then you really, really do need to look at COM Plus as an option. And with all of this, it's really like you design your application, and for different parts of your application, you say, well, this is what we need, and these are the possible technologies. And from there, you can really make good decisions. And if you do want to use these features, then please use COM Plus. Things like transactions are very, very hard to do, and you're going to lead into problems. And they might not be apparent at first. You try it on the development machine, it looks great. You try it on a small test case, it looks great. And then you go to scale out to your web farm, and suddenly nothing works properly. So here are some tips on tuning performance. The first one is something some people miss. If you're running on NT4 or Win2K, you will usually see a 40 or 50% performance improvement if you run in the IIS process. That does open you up to some security vulnerabilities. It does mean you need to be more careful in your code in terms of hackers being able to bring down your entire website. But then usually if you're doing an ISAPI application, you're only running one application or one or two applications on the machine. So if someone brings down the web server on that machine, they've really just brought down the one application they would have brought down anyway. If you're running out of proc, right, the only advantage is only that web application is disabled, the others still work. If you're running on Windows.NET Server, it actually changes. They've fixed the process model so you no longer pay that expensive cost. So you now can have the best of both worlds. But it's very important you keep that in mind when developing your application, because when you're developing, you often don't want to run in process. There are advantages in not having to restart IIS as often. Tune your application, and two of the easiest things to tune in ATL Server in particular are your thread pool and your buffers and caches. So for the thread pool, we usually find 4 to 6 threads per processor is about right. Although I've seen extremes where people have found 2 threads per processor and people have found 8 or 10 threads per processor to be the best. It's really just a variable you have to set. So go ahead and set it and try different values and run tests and see which works best for you. And make sure you tune your response buffers as well. That's a good example of a caching type system where you can do a lot of tuning and save yourself a lot of trouble. If all of your pages are only up to 20K, then make your response buffer, 25K, and you're going to fit everything in just one allocation. If 90% of your pages are 20K and 10% are 200K, well then tune for the 90% case, and then for those other 10%, you can actually just do the one allocation at the start of your request handling. And it comes back to, I guess, the general thing of trying to reduce the number of memory allocations in your application. Another way you can do this is taking advantage of things that, if you know things up before your application runs or a priori, then take advantage of that. For example, if you're going to use C-string, but you know the size of the string, well, use C-fix string, because there will be performance advantages in doing that. This is a point I can't emphasize enough, and it's really one of the main reasons I came here, and it's use tools. If you're working on a high-end application, a lot of these tools are free in terms of PerfMon and Task Manager, and that they come with the OS. A profile will cost you a little bit, but a profile is really one of the key tools in creating a real-world server application. A profiler will always help you find code bottlenecks. I've been in numerous situations where developers are sure where the problem is in their application in terms of bad performance, and they work on tuning it and tuning it. And occasionally they're right. Occasionally that's their biggest problem, and they fix their biggest problem. Occasionally they're wrong, and they spend all this time tuning an area where they weren't wasting time. There's only one way to be sure, the profiler. And one thing I'll point out in both those cases, I've never seen a situation where the profiler didn't add 10 or 20% in performance. Even if you're tuning the most problematic area, the profiler is bound to turn up other problems in your code. If you run the profiler and you don't find any problems, then please send me your resume, and I'll put you in for a development position at Microsoft, because it really will save you a lot of time and effort. We use profiling on ATL Server all the time. The technique I recommend for using all these tools, and I come to a bit later, is you really do need a dedicated lab set up, and you really do need something that at least mimics what your real-world environment will look like. Because with a real server-side application, and with an application where 10% performance is critical, a lot of that will just depend on network topology. We've run test applications in one test lab and then another test lab when we thought the labs are identical, and we've seen 10 or 20% performance difference. It really does make a big difference. So try and simulate your real-world environment as much as possible. And the other advantage of running something like this on a week-by-week basis is that as soon as someone checks in bad code, you know where the problem is, so you know where to start looking. And that can really be the problem. I mean, a lot of these sorts of issues, and when we come to stability, like timing issues and stuff like that come into play, they're really, really hard to track down. And the easiest way to track them down is going through all the code that was checked in. And if it's only been a week's worth of code, it becomes a very doable task. For something like PerfMon, it's a great way to just log statistics about your application while it's running. requests per second, your CPU utilization, how much network are you using, how efficient is your database usage. You can log all these. Perf1 provides a great set of utilities for viewing your application. You can view it from remote machines, so you can sit at home and cover it. It really is a very powerful utility, and with ATL, we actually have a bunch of performance monitor wrappers, which makes it really, really easy to expose performance monitoring from your application. There's actually a wizard that helps you do it. In terms of real time, while you're developing, the Task Manager is your best friend. It's amazing how many people don't take advantage of Task Manager to pick up quick leaks. You're leaking memory, you're leaking handles, you have strange CPU utilization. It'll show you straight away. And really, all of these tools work together to help you create the best application that you can without wasting a lot of time. I mean, they really do make you a lot more efficient. Another part of it, and another mistake people make, is they only look at their code. They assume if my code is good, then the application will be good. And sometimes that's not the case. If you're using third-party libraries or you're even using APIs, you really need to check for performance. And an example, for example, is we saw an application where it was taking locks, and it was really, really bad performance. And we didn't know what was going wrong. And it turns out, after running the profiler and narrowing down our testing, that it was the format currency API that was causing our problems. So even a very simple API call that you don't expect to take any locks can cause you problems. And again, by continuously checking, you can find these problems when they occur. And if they're very strange ones like this, you can find them a lot more quickly. Another part of tuning for performance is correct use of synchronization objects. And again, here you have two extremes. You have the guy who puts a sync object around everything, and a guy who never wants to synchronize anything. And you just need to understand when and where it's important. If it's important, it's better to be overly cautious. Timing issues are really, really hard to track down. If it's not likely to happen, then please don't waste a lot of processor time with these synchronization objects. And one of the important things to remember is handling even an asynchronous HTTP request. So even if you're handling them asynchronously, it's inherently a single-threaded operation. And therefore, you don't need to have synchronization objects in general. A good place where you do need synchronization objects is ISAPI globals. If you have a global variable that you're exposing, you can have multiple application DLLs trying to access it. So it will need to be synchronized, but only on writes. Obviously, if they're just reading from it, they won't need synchronization. So just look at the issues involved and try and make sure you don't take unnecessary synchronizations, because they really will kill your performance when you start scaling up. Data access is really important, and I have two slides, I think, on data access. This one has some, and the next one. Data access is really important because you have to test it for your specific database. I've seen people running on databases and assuming that their code is going to be efficient, and then it kills them. They test out on SQL 2000 on their development machine, and in their real world they're running SQL 6, and the performance is absolutely completely different. You have to tune for your database, and you have to choose the right access provider for that database. For many applications, OLADB is going to be faster than ADO. You need to weigh up the performance development cost time there. For other applications, particularly if you're using an older database, ODBC might be the best provider available. It's even worth going through and getting some trial versions of databases. I know most database vendors do provide developer trial editions. And test it out in your test lab and see what it's like. Because if a database is going to give you a 50% perf win or even a 30% perf win, buying a new database is going to be worth the cost right there. And again, like I said, you have to run performance tests throughout your development cycle. And this means over the network as well. I've seen time and time again people run local numbers and publish them, and you run it over the network and it just doesn't work. Another point with using databases is use the database. We have seen people try and recreate transactions either with Complus or on their own instead of using database transactions because they thought they could do it better. And the fact of the matter is, unless you're a database expert, you're not going to do it better. The database will always do a better job. Another thing is people write good database code and then they abuse it. They hit it all the time. There's no need to hit the database on each request for more than one select query, more than one update query, and more than one insert. And if you use stored procedures carefully, you really can limit the amount of database hits you have. And it's always going to cost you if you hit the database. The other one, obviously, is caching. Nothing is faster than just caching it and spitting it straight back to the user. Anything that is going to be hit, commonly cache it. You can expire caches on a day basis, on an hour basis, on a month basis. So even if it's just going to be for a couple of hours, everyone's going to hit this thing, then cache it and make your application really, really fast. This slide I'll glance over because we started a little late. We're running out of time. But if you do use XSLT, it provides a lot of benefits to your application. Use it wisely is the only real caution there. If you're going to do the processing on the server side, be aware of the potential cost and understand that it may not be efficient to process it dynamically. It might be better off to process it beforehand. And if you are going to process it beforehand and you do need dynamic content, often we find generating SRF files, which is the ATL server dynamic file, is a more efficient way to do it. Stability is very, very important. Before your application had to run for an hour or 3 hours, now it has to run 24/7. You're talking about a high-end server application. It's really important that you use a web stress tool. Microsoft Application Center Test is just an example. Any web stress tool will do. Something that pounds your application. It's really important you run this in the lab, that you use it for performance numbers, but be careful you understand your web application stress tool. A lot of times I'll see people who come to me and they're like, man, the performance on this is great, we're kicking ass. And then you go and look at their application and you go and look at their stress results and you find out they're just returning error pages all the time. So of course it's going to be lightning fast. And make sure you do runs for multiple days. I mean, check, are you going to leak memory? Are you going to leak handles? I mean, leaking a little bit of memory or handles may not seem like a bad thing, but if you're going to be up all the time, it's going to cause problems. So make sure you use the perfmon and task manager to monitor what's going on and do runs for like 3-4 days at a time. You will find bugs. Security is also very, very important. I can't emphasize how important it is, especially if you're writing a high-end web application. So the marketing people made me put JScript.net in there. Personally, I prefer to use Perl, although whatever you like is fine. Both languages have HTTP client libraries that make it very, very easy to send complex requests to your application. And another flaw people make is, oh, the UI doesn't allow that, so people won't do that. Well, someone malicious will. So it's important that you try it out with these scenarios. What happens if a header isn't quite terminated correctly, or some data you're expecting isn't quite in the format you're expecting it? You don't want to end up getting caught in infinite loops. You don't want to end up ever copying user input into a statically allocated buffer. If they overrun that buffer, you're basically saying it's okay for you to take control of my machine. People think there's a big trick to finding security bugs, or there's some magic solution. And the answer is there isn't. Like many of the difficult problems in life, the only way to find security bugs is take the time and take the effort. And you don't need any special expertise. You really just need, a day of reading up is enough to find, the common bugs. And the only way to do it is code review. And the best way to make the most out of your code review is to look for the right things. Look for statically allocated buffers. If it's statically allocated buffers and you can overrun it, it's going to lead to problems. Look for where you dereference pointers. Is the data valid? You should take your user input, and that's cookies, that's request parameters, that's HTTP headers, anything that comes across the wire, and you should track that through your entire application. And you should make sure you're always validating it and that there's nowhere where you're copying it into statically allocated buffers without checking it. Make sure you're handling input correctly, and part of that is not getting stuck in infinite loops. It's very possible if you're waiting for a particular formatted message to just get stuck and never return. Also, make sure you understand multi-byte characters and how they'll affect your application. A lot of users might do this by accident. They might send you a multi-byte characters. How will your application respond? With Visual Studio.net, we've got a great way to help you avoid common buffer overruns. Your application will crash and will not give the person access to your machine. and that's the /GS switch, which is on by default in ATL server. Please make use of it. It's usually a 2% performance hit at most. If you see a significant performance hit, again, send us mail. It's a bug. It really will help protect you. It's designed to make your code more hack resistant. You can also use modern C++ programming techniques to make sure your application is fairly safe. An example of that is using templates to have the compiler check your static string copies. An example of that is the safe string copy. And that shows you how you can use modern techniques and templates to actually have the compiler check at compile time a lot of these issues for you. So this is actually my last slide. For those who are worried I'm running over time, again, I apologize for that. This is some common issues people run into and just some things to look for. And again, all these things look really obvious when I point them out to you on a slide. When you have a real-world application, they're not that obvious. Even for people who know what to look for, they're not that obvious. So it really does help to go and take the time and just check things off a checkbox, or have people on your team check things off and make sure they've checked them properly. If you have low requests and low CPU utilization, the most obvious problem is that you're taking locks somewhere. Your threads are probably getting blocked. An example of that would be our format currency API, which takes locks we didn't know about, and the profiler is the best way to find those. If you have low requests per second, but your CPU is pegged, you obviously have some inefficient code. It might be infinite loops. It might be your code is much more complex than you thought it was. And maybe you can't change it, and maybe it means you just need a more powerful server that can handle the load. If you have very low CPU utilization, but very high network utilization, you have to check your network and handle the load. And this is a problem we see often. You know, people are wondering why their performance plateaus and they're running on like a 100 megabit network. Well, maybe you do need a gigabit network or something. It really will depend. Some internal applications for their internal communication will require a lot of bandwidth.